Alright, so I'm going to do a short video here on how to use that normal curve. Let's suppose I want to find P of Z less than 1. So I draw the beautiful curve here and make my sketch like this, and here's 0 and here's 1.0. Alright, so I want to find the area less than, that's to the left, right? So what I would do is, to go do that, I just need to go look at the normal curve. I want to go find 1.0. So 1.0 is down here a little ways, right here. So 1.0 in the curve, so that means the area to the left of 1.0 is 8.8413. So I go back here and I know that the area this way is 0.8413. And so this probability is equal to 0.8413. That's it. That's how you do the less thans. And the reason that just works that simple is because the table is set up so that the numbers inside here, inside the array, these numbers in here, are the areas to the left of these z-scores. So like this area is the area of the shaded part over here that's to the left of negative 0.341. So it's always, these numbers are always to the left. So let's go back and do a different kind of problem. Suppose I wanted to find P of Z greater than 1.0. Well, I draw the same kind of picture. I always start these kind of problems with a beautiful curve, and here's 0 and here's 1.0. But this time the greater than is telling me I want to find the area to the right. Well, I already know the area to the left is 0.8413 because that was from the table that I just had an example. But I want the area to the right. Well, the area under this normal curve is always equal to 1. So the way to find this area is to take 1 minus 0.8413, and that's going to be equal to 0.1587. So this shaded region now is 0.1587. 1587. Now there is another way to do this. Let me get bold here, and I'm going to change the color of the pen. Alright, so I know the graph is symmetric. So if I were to find this area over here to the left of negative 1.0, it would be the same as this area over here. So I'll go to the table, and I'm going to look up negative 1.0. Scroll down a little bit here. Negative 1.0 is 1587. And let's go back to my chart here. And by golly, it's 1587. So there's two ways to find the area to the right, but there's only one way to find the area to the left, and that's just to look it up in the table. There is one more kind of problem that you're going to have to do, and that's going to be like one where it's like in between. So I want to find, like, what's the probability that negative 1.0 is less than z is less than 1.0. Well, when I draw that picture, I draw my beautiful curve. I do this guy here like this. I know that's 0. 1.0 is over here. Negative 1.0 is over here. And I want to find the area between them. Well, there is no easy way to do this. You just got to look up both numbers. So this number here we already know is 0.8413. And then from the table just a minute ago, this was 0.1587. And I want to find the area of the shaded region, so that's going to be found with P of Z less than 1.0. That's this area from here over, this area up here, minus the area over here. And so that's going to be P of Z less than negative 1.0. And we do those guys, we got 0.8413 minus 0.1587. So we're going to take these guys and do that math. So I got 0.8413 minus 0.1587. 0.1587, and that turns out to be 0.6826. So the area between here is 0.6826, but we should have probably recognized that as the empirical rule. You'll remember, if you have a normal distribution, a normal curve, and you have 0, if you're one standard deviation above and one standard deviation below, then this area is 68% of the distribution. Now, it's a little off. They just round this off so it's easier to remember. Each one of these is 34%. That was what the game was. You could play around with this for days, but that's good enough. Right, so that's shortcuts at how to use the table and how to use the normal curve.